Hello everyone, this is Gordon. We're beginning a set of solved problems in physics on motion in a vertical plane. We have equations for falling bodies that relate height and time. We have relationship between velocity and time. We can use this equation for time as a substitute and come up with a relationship between velocity and height. For projectiles, we have an equation that gives us range and one that gives us time in flight. Our first question: a stone dropped from a bridge hits the water 2.5 seconds later. We're asked to find the final velocity of the stone and the height of the bridge. Using the relationship between velocity and time, we have a gravitational constant, 9.8 meters per second squared, times time, 2.5 seconds, gives us a final velocity of the stone as 24.5 meters per second. How high is the bridge? We have height is equal to 1/2 gravitational constant times time squared, which is equal to 1/2 times 9.8 meters per second squared times 2.5 seconds, quantity squared. And when we do the arithmetic, we come up with a numerical value of the height, 30.6 meters. Our second problem: a ball is dropped from a window 64 feet above ground. How long does it take to reach the ground, and what is its final velocity? Again, we're given height as 64 feet. We're asked to find time and velocity. Using the equation that relates time to height, we come up with time is equal to the square root of 2 times h times g, which in this case is 2 times 64, and that's 64 feet, divided by 32 feet per second squared. I'll go ahead and make that correction. Get the units in there where they belong. And so this is going to equal the square root of 2. And then we take a quick look. 64 divided by 32 is also 2, and it's going to be in seconds squared. 2 times 2, square root of that is 2 seconds. And there's the answer. The final velocity, we'll use the 2 seconds that we just got. And we've got 32 feet per second squared as the gravitational constant, and the time, 2 seconds, for a final velocity of 64 feet per second. Our third problem: what velocity must a ball have when thrown upward to reach a height of 30 meters? And this is a terminal velocity question with a height of 30 meters. If you think about it, you're at the ground, the ball going straight up. You're looking for, you know that the final velocity is 0, and you want to know v sub 0. This is just an upside down terminal velocity question. And so we have v is equal to the square root of 2 times the height times gravitational constant. Here it's 2 times 30 meters times 9.8 meters per second squared. See the units, the answer is going to come out in meters per second. And when we do the arithmetic, we come up with 24.5 meters per second. The fourth question: if a ball is thrown downward with an initial velocity of 4 meters per second, how fast is it moving after 2 seconds? And how far has it gone? We've got v sub 0 as 4 meters per second. T is equal to 2 seconds. And we're asked to find v and s. You'll remember from our earlier problem set, v is equal to v sub 0 plus the gravitational constant times time. We substitute numbers in. It's 4 meters per second plus 9.8 meters per second squared times the 2 seconds that were given. And when we do the arithmetic, we come up with 23.6 meters per second. The distance that the ball has traveled is going to be equal to v sub 0 t plus 1/2 at squared. Again, equation from an earlier problem set. Excuse me. We have v sub 0 is 4 meters per second. We multiply that by the 2 seconds that were given, and then 1/2 9.8 meters per second squared times 2 seconds squared. And we get the first term comes out to be 8 meters. The second one, a half times 9.8 times 2 is 9.8 times 2, 19.6 meters. Add those two numbers together, and we get 27.6 meters. Our final problem, an airplane is in level flight at a velocity of 300 miles per hour and altitude 5,000 feet when a piece of luggage falls out. We're asked to find when, where, and at what velocity does a piece of luggage impact the ground. Again, v sub 0, 300 miles per hour, height 5,000 feet. And so the first thing we can look at, after writing down what it is that we're trying to find, which is distance, time, and velocity, we can go after, velocity of course is going to be the components of the horizontal and the vertical velocity. So the amount of time it takes to reach the ground is going to be, as before, 2 times the height divided by the gravitational constant. That will be 2 times 5,000 feet divided by 32 feet per second squared. And when we do the arithmetic, we have a numerical value of time as 17.7 seconds. And that gives us the opportunity to calculate the final velocity. We need to convert 300 miles per hour to feet per second. And we have a conversion factor of 1.46 feet per second is the same as 1 mile per hour. So our initial velocity v sub 0 can be expressed as 440 feet per second. So the distance that's traveled while a bag is falling, that 5,000 feet, is 440 feet per second times 17.7 seconds. And when we do the numbers, we hit 7,790 feet away from the point where the piece of luggage actually left the airplane. The final velocity, the impact velocity, use the Pythagorean theorem. It's going to be the sum of the squares, the square root of the sum of the squares of the horizontal and vertical component of the luggage velocity. Of course, the x component is 440 feet per second. The y component of the velocity is going to be gravitational constant times time, which is 32 feet per second squared times the time that we calculated, 17.7 seconds. When you do the arithmetic, you come up with a velocity in the y direction of 566 feet per second. So the impact velocity will equal 440 squared plus 566 squared. The answer, of course, will come out in feet per second. And we come up with a final value for the velocity, 717 feet per second. And that's the end of the set.